Hello everyone. Today I'm going to discuss the last problem of Leetcode Weekly Contest 450, which is minimum weighted subgraph with the required paths 2. So what is the problem? So we are given some weighted undirected tree, okay, of n nodes, and we are also given queries, okay. In a each query we are given three values: source 1 and source 2 and destination. So we have to return an answer of equal length where answer J means the minimum total weight of subtree such that it is possible to reach a destination J from both source 1 J and source 2 J. So let's take the first example only. This is the given tree. Okay. Now for the first query, the source node, first source node is 2, the second source node is 3, and the destination node is 4. So if we want to take a subtree which where destination node is reachable from both source 1 and source 2, then it will be like this. Okay, so let me take the example. So the destination node is like this: 0 1 2 3 4 and 5. Okay, 4 and 5. Now my source 1 is this, source 2 is this, and my destination is this. And if I want to take a subtree, if I want to take a subtree which where every node, like the destination node is reachable from source 1 and source 2, then we can take this subtree. Okay, we can take this subtree. Then the destination 4 will be reachable from both 2 and 3. So now first observation, one observation that we can make from here only is that if source 1 is like s1 is reachable from d1, sorry, d1 is reachable from s1, and s2 and d2 are reachable, then we can obviously say that s3 and d3 are reachable, sorry, s1 and s2 are reachable, right? Sorry, let me write it again. So source 1 and destination is reachable, source 2 and destination is reachable, then we can say that source 1 and source 2 is also reachable. Okay. So one observation we can make. So we have to find a subtree where each node is reachable from each other. Okay. So that is the first observation we had made. Okay. Now you can see that the answer for this will be 3 plus 5 plus 4, which is 12. Similarly, for the second query, here you can see that the source 1 and source 2 are 0 and 2 respectively. So source 1 is this one. Let me write it in this color. So source 1 is this one, and source 2 is this one, and my destination is 5. So what is the tree? What is the tree subtree we can take? We can take this subtree. Okay, we can take this subtree. Then each and every node will be covered. Okay. Now we'll come to how we can solve this problem. Uh, for that, let's discuss the constants first. So n is 10 to the power 5, n is 10 to the power 5, and queries are around also 10 to the power 5, I think. Let me check. Queries are 10 to the power 5, and queries are also 10 to the power 5. Okay, queries are 10 to the power 5, and number of nodes are also 10 to the power 5. So order of solution could be like order of n plus q, or order of n plus q log n, or order of n plus q log n, kind of order of n log n, you can say. So now one observation I had made during the contest is that let's say there is a tree like 1 2 and 3. Okay, my it does not matter which one is source and which one is destination, because I have already told that if s1 and d is reachable, s2 and d is reachable, then s1 and s2 is reachable. So it does not matter which one is source and which one is destination. Okay, so let's say these three are the nodes. Okay, these three are the nodes. Then what I can say, I can say that from 1 to 2, let's say this is w1 and let's say this is w2. Okay, so let's say what is the distance from 1 to 2? So distance from 1 to 2 is nothing but w1. And what is the distance from 2 to 3? The distance from 2 to 3 is w2. And what is the distance from 1 to 3? The distance from 1 to 3 is w1 plus w2. So if I take the sum of everything, if I take the sum of everything, it will come as 2 of w1 plus w2. Okay. Now this is one example. So I have taken various examples. I don't currently have the proof of how it works, but I'll explain my solution. So let's say this is like another example. Let's say 1 2 3 4, and let's say this is 5, and they say ages are like w1, this is w2, this is w3, and this is w4. So let's say my nodes are like 3 4 and 5. So the distance from what is the distance from 3 to 5? The distance from 3 to 5 is nothing but what it is, like it is w3 plus w1 plus w2. let me write w3 plus w1 plus w2. What is the distance from 3 to 4? The distance from 3 to 4 is nothing but w3 plus w4. And what is the distance, another distance? Let me take it. Another distance will be like from 4 to 5. The distance from 4 to 5 will be like w4 plus w1 plus w2. w4 plus w1 plus w2. Now if I take the summation of all this 3 to 5, 3 to 4 and 4 to 5, then what I can get, then I will get like 2 into w1 plus w2, like 2 into w1 plus w2 plus w2 plus w3 and plus w4. Okay, so from this what we can see from these two examples, and I have taken other examples also, what we can see is that if I take the distance from all the three pair of nodes, like let's say we have I j k, then let's say we take distance from I to j, I to k and k to j, and if I sum them all up, then we get our desired answer into 2. Okay, so because we are, our answer is w1 plus w2, right? The number of total ages w1 plus w2, sum of the ages into 2 we are getting. Here also we are getting 2 into this value, sum of the ages. So if I take the sum of everything, like if I take the sum of distance ij plus distance uh, jk, and let's say distance I to k. Okay, if I take the sum of all this, and let's say we take the divide it by 2, then we get our answer. So our answer is nothing but distance of ij, distance of jk plus distance of ik by 2. Okay, now uh, now the problem comes to how we can find a distance of any two nodes in the tree. Okay, we have to find the distance of any two nodes in the tree. So one possible solution could be to do a bfs from each and every node. So do a bfs, do a kind of bfs from each and every node. So that solution will have time complexity of order of n square. So we can't do that, right? We can't have order of n square solution, because n is 10 to the power 5. So we have to think something better. So the better solution is to use lcs. So let's say this is the tree, like 1 to 2, 2 to 3, let's say this is 4, 3 to 4 and 2 to 4 to 5. Okay, now the lca of 3 and 5 is, the lca of 3 and 5 is 2. So if I take the distance from LCA means what? LCA means lowest common ancestor. Okay, LCA means let me write it here. LCA means our lowest common ancestor. So we have to find LCA of the two nodes. Okay, if I find the LCA of two nodes, and if I take the distance from the first node 3 to 2 and the distance of 5 to 2, if we add them up, then we will get our desired answer. Now how we can find the LCA of a node? Okay, so this is also an interesting algorithm, how we find the LCA of a node. Okay, I am going to explain the algorithm. If you want some details explanation, you can check YouTube videos also, but here I am going to explain over the top, you can say. So what is it? So let's say 3 and 5, we have to find the lcs. So for each node we'll have some like what is the parent node. Okay, so the parent node of 3, the parent node of 3 is 2. So let me write it here. So let's say 3 and 5, let me draw this graph again. So we have something like 1 to 2, 2 to 3, and this is 2 to 4 and 4 to 5. So we'll have zero level node, zero level parent. Okay, zero level parent means immediate parent. So immediate parent of 3 is 2, immediate parent of 3 is 2. Okay, now first level parent means like we are using power of 2's. So 2 to the power 0, 2 to the power 0 means that's the first parent. Okay, 2 to the power 0 means the first parent. So first parent of 3 is 2. So 2 to the power 1 means the parent of 2 level. Okay, so parent of 2 level will be 3 to 2 and 2 to 1. So parent of 3 is second parent of 3 is 1. Similarly for 5, similarly for 5, uh, the parent of 5 is 4. Okay, parent of 5 is 4. Now the second level parent of 5 is, second level parent of 5 is 2. Okay, second level parent of 5 is 2. Now the fourth level parent of 5 is not 1, because we will have to go 2 to the power 2 means 4 level. Okay, so 1 2 3 and 4. So we can say that 1 is connected to an above node -1. So the parent of 1 is -1. So second level parent of 5 is -1. Okay, like that. And after the second level, 2 to the power 3, 2 to the power 4, like that, the other parents are also -1. So similarly for 3, the second level parent is -1. So we have to find the uh, level parents of 3 and 5. Okay, we call it LCA IJ. So LCA IJ means the jth level parent of I. Okay, jth level parent of I. How we can find it? So you can see that the jth level parent of I is nothing but, it is nothing but LCA of, it is j minus 1th level of parent. So we can say that j minus 1th level of parent, LCA of I comma j minus 1, and uh, jth level, j minus 1th level parent of j minus 1th level. Okay, so let me explain it again. So let's say this is some path graph. Okay, like that. So what is the 0th level parent of 1? 0th level parent of 1 is 2. Now we can say what is the first level parent. 2 to the power 1th level parent of 1 is nothing but the 0th level parent of 2. The 0th level parent of 2 is 3. So we can say that uh, first level parent of 1 is 3. Similarly, what is the fourth level parent, second level parent of 3? Okay, what is the second level parent of 1? The second level parent of 1 is the first level parent of 1, which is 3, and its first level, its first level is 5. So first level parent, second level parent of 1 is 5. That's what, how we are calculating. So I will explain in my code now. For detailed explanation of LCA, I will attach some link in the description box. You can check that out. Okay, so I am just explaining over the top. Okay, so here we are calculating we are using one DFS. In a DFS, we are calculating LCA of the 0th level. The 0th level parent of any node is the parent of that node. Okay, LCA of j0 is I. So we are passing the parent, and whenever we are at a child of a node, we are adding LCA of j0 as I. Okay, the 0th level parent of child node is the current node. Okay, and distance of j0, is w. So distance of ji is nothing but the distance from uh, the current node to the LC of jth level. Okay, so distance of ij is the distance between I and LC of ij. Okay, distance of I and LC of ij, that is the, that is nothing but distance of ij. And here I am calculating the value of LCA. LCA of ij is LCA of ij minus 1 and j minus 1, and distance of ij is distance from the j minus 1th level parent to the to its j minus 1th level parent, and distance of this current node to its j minus 1th level parent. Okay, I hope you are getting it. You can take some examples to grasp what is happening here. So how, this is how we are calculating the distance between a ith node and its jth level parent. Okay, so here we are calculating that LCA. So this part is done, and the next part is finding LCA. Okay, this second part is finding LCA. That is also one important algorithm, which is called binary lifting. So let's say we are trying to find the LCA of two nodes. Okay, let's say this is 3, this is 4, and this is 5. Okay, we are trying to find the LCA of 3 and 5. Okay, now first we'll check that if we are assuming that u and v is called. Okay, so we are assuming that the depth of u, this the depth of u is greater than depth of v. So here let's say we called that find LCA of 3 and 5, because here u is 3, here you can see that u is 3 and v is 5. Okay, but you can see that u depth of u is less than depth of v, so we'll change it. So we'll find for u equals to 5 and v equals to 3. Okay, now what we'll do, we'll try to take them at the same level. So we'll try to take u at the same level. We'll try to take u at the same level. Okay, so for that what we can see, let's check the code. So you are checking that if level of u is less than level of v, so we always guarantee that level of u is greater than level of v, so we are swapping in that case. Now we are checking that we are taking every bit. Okay, and checking that if level of u minus 2 to the power I is greater than level of v. So here level of u is 1 2. So here level of this is 2 and 1 2 1 2 3. Okay, so this is 3. Okay, so we are checking that if 3 minus 2 to the power 2, 3 minus 2 to the power 2 is greater than equals to 2. No, it is not greater than equals to 2, so we'll skip. Now at the end we will get 3 minus 2 to the power 0. It is greater than equals to 2. Yes, it is greater than equals to 2, so we'll jump by one node. Okay, so here you can see that if it is greater than equals to level of v, we are taking the distance as distance ui. We are taking distance as we are jumping one node, so we are adding the distance. We are adding the distance and we are jumping ith node up. Okay, now if by jumping this there could be one case, let's say like this 1 2 and 3. So we are trying to find lc of 2 and 3. So by jumping one node we have achieved at our desired lca. Okay, so if u equals to v, that means we have achieved our lca. So we are just returning u and d. So first pair means the lca and second pair means the distance to lca. Okay, so I hope you are getting it. And second case is also doing binary lifting. So here after doing making them at the same level, my u is now 4 and v is now at 3. So we are at 4 and 3. So we'll jump one node up. Okay, we are trying to jump. Okay, so until lca ui not equals to lca vi, will jump. Okay, so at the end we'll achieve some node. Let's say we will achieve at some node. Let's say we are like this. Okay, 3 4 and let's say 5 and 6. Let's say we are at 4 and we are at 6. So we'll at the end we'll achieve to 3 and 5. And whenever we are at 3 and 5, at the end we will be at 3 and 5. So we'll return lc of u0. lc of u0 will be 2. Okay, so we will not make a jump of 2. We will not make a jump of 2 length. So that's why we are always checking that if lca ui not equals to lca vi. Okay, so if we make a jump of 2 nodes, then we'll at lca of ui is 2 and lca vi is also 2. We'll not make a jump of 2. Okay, so if lca ui not equals to lca vi, we are doing d plus equals to distance of ui plus distance of vi. So I hope you are getting. So if we make a jump of length greater than equals to 2, the lca of ui and lca vi will be same. So we'll make jump less than equals to 2, less than 2. Okay, and at the end we are returning lca u0 and d plus distance u0 plus distance v0. I hope you are getting it. So that's how we found the distance and lc of these two nodes. Okay, so for each query we are finding 3 lcs. So at first we will get the distance of x to y, and then we can get the distance of x to z, and then we can get the distance from y to z. So let's call it d1, d2 and d3. So if we take the sum of d1 plus d2 plus d3 and divide them by 2, then we get our desired answer. So d is nothing but d1 plus summation of di by 2. Okay, so this is, I have already explained this earlier why it is happening. Okay, and overall time complexity solution is order of n plus q into 20. So why 20? 20 is always log of the number of nodes in the tree. So 20 is nothing but log of number of nodes in the tree. For safety we have used 20 here. We can take log of n also. Okay, I hope you get it. I will attach some article or YouTube video link for finding LCA using binary lifting. You can check that out. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. I'll also attach the code link in the description box. If you find this video helpful, so please like the video, subscribe to the channel, and also share among your peers. Thank you.